Aldehydes are oxygen derivatives that contain carbonyl group CO bonded to two other atoms. The bond between carbon and oxygen is double bond. Aldehydes have one hydrogen atom and one alkyl or aryl group attached to carbonyl carbon atom. The group is planar, in other words, it is found in a plane with 120 degrees angles between bonds. The carbonyl group in aldehydes is always found on the end of the chain, and the molecule's name ends with Al. An aldehyde is created from an alcohol, let's just say methanol, or CH4O, which is oxidized to form methanol, also called formaldehyde, which has a chemical formula CH2O. Another example is oxidation of ethanol, C2H6O plus O get oxidized with the help of sodium dichromate, Na2Cr2O7, and sulfuric acid H4SO4 to ethanol C2H4O plus one molecule of H2O. This is where name for aldehydes comes from. Alcohol dehydrogenatum Al plus dehyde, and we just add E at the end. The simplest aldehyde that we can make is formaldehyde, because it has just one carbon that has one oxygen and two hydrogen attached to it. It's also the most used one. It's used for its preservative properties in a solution called formalin, which is used for storing biological preparates. Electronegativity of oxygen atom is 3.5, while the electronegativity of carbon atom is 2.5, so the double bond between them is polarized. Oxygen acquires fractional negative charge, while carbon acquires fractional positive charge. Since the carbonyl group is reactive, most reactions take place on it. This also means that hydrogens don't have intermolecular hydrogen bonds. An interesting thing about aldehydes is, in small amounts, they smell really nice, but in higher amounts, they really stink. One example is cinnamaldehyde, C9H8O, which smells, you guessed it, like cinnamon, but in higher amounts, it smells real bad. Aldehydes are often found in organisms that are alive, but we can also make them synthetically. Boiling point depends on molar mass, because with increasing molar mass, the amount of electrons also increases, which increases the amount of dispersion forces between molecules, thus increasing the boiling point. The polar carbon-oxygen double bond causes aldehydes to have higher boiling points than derivatives such as ethers or alkenes of similar molar masses, but lower than those of comparable alcohols that engage in intermolecular hydrogen bonding. A typical reaction of an aldehyde is a nucleophilic addition. It is a reaction in which an aldehyde reacts with an alcohol. It is a reaction that takes place mainly in a clean environment, which means in a free hydrogen cation environment. The free hydrogen cation first bonds to the oxygen in the carbonyl group, making carbon and carbonyl group positively charged. The rest of the alcohol then bonds to the carbon, creating hemiacetal. If the reaction continues, an acetal is formed. It is very important from the point of view of carbohydrates, because with carbohydrates an intramolecular polyacetal reaction takes place, and thanks to it we can find out why some carbohydrates are reducing and some are not. Oxidation of aldehydes is a reaction where an aldehyde changes to carboxyl acid. The oxidation takes place with the help of various reagents, and we can also use it to prove the presence of aldehyde in the sample. We can also use Fehling or tolerance tests to determine if there is an aldehyde in the sample. In Fehling, we use potassium sodium tetrate and copper 2 sulfate as oxidizing agents. They get reduced to copper 1 oxide, which is red. Aldehyde gets oxidized to carboxylic acid. Tollens reagent is the solution of alkaline silver nitrate, AgNO3, combined with aqueous ammonia solution, NH4OH. Pure silver that was created forms a silver mirror on the surface of our container, and aldehyde gets oxidized to carboxylic acid. Aldehydes with shorter carbon chain can be dissolved in polar solvents, but all of them can be easily dissolved in nonpolar solvents. Another interesting aldehydes are 3-methylbutanol, smell of chocolate, 2-methylbutyl aldehyde, smell of nuts, vanillin, smell of vanilla, and benzaldehyde, smell of almond. For activity, do failing test. The procedure is explained in this video. Okay, let's get to the nomenclature. So, here we have carbonyl functional group, with one exception. This is the aldehyde functional group because it has this one hydrogen. If instead of hydrogen there was another R, it would be a carbonyl functional group. If there was anything else except hydrogen, it would be a ketone functional group, because ketones are located in the middle, let's just say here, of our molecule. It's a hydrogen because it's at the end of the molecule. This R represents aryl or alkyl group, which is, for example, this thing. This thing is an alkane with 1, 2, 3, 4 carbons, so it's a butane. Then this butane gets oxidized, forming an aldehyde with 1, 2, 3, 4 carbons. Remember, the counting starts always with the functional group. If there are multiple of them, the functional group has to have the lowest possible number, in this case 1. So we have 4 carbon aldehyde, which means that it's butane plus al. Let's write it. Butanol, also known as
butyral or butyral.
Then we have this guy. This aldehyde has 1, 2, 3, 4, 5 carbons. So it's a pentanol. But we also have bromine in here. So we need to add that to the name. So it's gonna be 4-bromo pentanol. It doesn't fit. Give me a second. 4-bromo pentanol. Got it? Good.